All right. Hi there, algebra students. It's Mr. Pouts. Um, we're going to do lesson 3.4 here. And lesson 3.4 is right here entitled Solving Multi-Step Inequalities. So what you could do right now is take your goal sheet out and write down the goal for today. Make sure you write this down because this is what we're focusing on. Our goal is to solve multi-step equations. It's as simple as that. And the way we're going to do it in this video is we'll review the steps to solving multi-step equations, which is going to be the exact same thing as multi-step inequalities. The only thing that you have to remember is the negative rule. So if you do that, but we're going to go through about 4 examples. So that's how we're going to do it. I would suggest writing them down, following along for each of them. So the first example is going to look like this, and this does say problem 1. And I'll move this down so we have it out of here. So problem 1 says, what are the solutions to n plus 4t is greater than 21? So we want to essentially solve for t. All right, here are the steps that I'm gonna show you for any multi-step equation. Not all these steps will apply to all these, but it is the same as solving multi-step equations. Only we have inequality symbols. So the first step would be to simplify each side by using the distributive property and by combining like terms. And this again, this is just if you can. So I'll put if need be. But our first example, you'll see we don't actually have any distributing. We don't actually have any combining of like terms. So we can skip that step. Step 2 would be getting the variable terms on the same side by adding or subtracting. So if there's variables on both sides, remember we have to get rid of them from one side by adding or subtracting that term to make it so we have it only on one side. And again, this is only if there's variables on both sides. Next would be move the constant to the opposite side of the variable term. So if there's a constant added or subtracted to the variable term, we should do the inverse and move it away from that side. And then lastly, isolate the variable if there's a coefficient in front of it by using multiplication or division. So if there's a coefficient in front of it, you divide. If it's divided by something, you multiply. Now I do want to add in one thing that wasn't here before. Don't forget to use the negative rule. And I'm actually going to type up the negative rule here again for you because people tend to forget that it only works for, it only is applicable for certain situations. So the negative rule here is um, if you are, if you multiply or divide each side, now we're, can't even see it anymore. So I'll do this, bring it down a little bit. If you multiply or divide each side by a negative, then you must reverse the inequality symbol. So when we're dealing with inequalities, if you have to multiply or divide either both sides by a negative to solve it, then right when you do that, you need to reverse the symbol. And we've done that before. Now we're going to do an example. We'll see if we have to use it here at all. We'll see what steps we have to use actually for this as well. So, problem 1 says using more than one step. What are the solutions to this? Now imagine it being like an equation. I'll write an equation up here. 9 plus 4t equals 21. Now for that, we're trying to solve for t, so we have to isolate the variable. There's no like terms on either side. There's no distributing. There's not even variables on both sides, so we can just skip to getting rid of the um, constant term. So if it was an equation up here, we'd subtract 9 from both sides to get rid of that constant term. We're going to do the same thing here. We're going to subtract 9 from each side. Here's like our wall to cancel out that positive 9. that's added to the 4t. So we just have a positive 4t left here. Is greater than 21 minus 9 is 12. All right, same thing would happen over here, only it'll be 4t equals 12. And then the last step in our equation, if we were dealing up here, we'd have to divide by 4. That's the inverse of multiplication, so t equals 3. But since we're dealing with an inequality, so I'm going to put that to the side, we do the same thing, only we have an inequality symbol in our answer. So it'd be 3. Now there's no negative rule being used here because there's no multiplying or dividing by negatives. So our inequality is simply t is greater than 3. Again, if you would graph that, you'd make your number line. You could have 0, 1, 2, 3, 4. Start at the 3. Greater than would be an open circle going to the right. All right, let's do another one. Skip into problem 3. Here's one where we have to use some distributing property and like terms in it. So that's our first step, is to see if there is any distributing or like terms. We can make our wall. But if you look here, that distributing should be your first step. Don't do anything with anything else until you distribute. So if we distribute the 3 to the t and the 3 to the 1, because that's what's inside of the parentheses, we will have 3t plus 3 times 1 is 3 minus 4t, or plus negative 4t, is greater than or equal to negative 5. So we're done with distributing, but if we look here, we have to simplify each side by distributing and combining like terms. So to finish that part, we have to combine the like terms, which we have are 3t and negative 4t. Are added together to get us negative 1t plus 3 is greater than or equal to negative 5. Done with that step. So if we look back here, let's go to step 2. Get the variable terms on the same side by adding or subtracting. The variable terms are already on the same side for this problem. Whoops. Okay. The variable terms are already on the same side, so we can just skip then to number 3, which now we're just like a two-step equation. Get rid of the constant from that side. So to get rid of this constant, which is the plus 3, since there's no variable attached to it, we're going to do that next. We're going to do the opposite, which is minusing 3. We're left with negative 1t is greater than or equal to negative 5 minus 3 is actually negative 8. And we have one more step to isolate t, and that would be to get rid of the number in front of the t by dividing by negative 1. Aha! Let's look back at our negative rule. If you multiply or divide each side by a negative, so that's what we're doing, we're dividing, then you must reverse the inequality symbol. So if we go back here, I'm going to reverse that symbol right away before I forget. These cancel out to get t by itself. And negative 1 divided by negative 8, or negative 8 divided by negative 1 is positive 8. 8 divided by 1. And that would be your inequality. Alright. So following all those steps, that is the way to do it. I'm going to give you a couple more challenging ones now. We're going to add for this next problem, this third one, it's actually problem 4. We skipped problem 2. Now what's different about this is we have variables on both sides. So variables on both sides. We first want to check to see if there's any distributing or combining like terms. Again, that's what we had to look for. Step 1, there is none of that. We're going to skip it. Go to number 2, get the variable terms on the same side by adding or subtracting. So if you remember from when we solved it like an equation, we can still make our line here. We want to get the variable term, we're going to subtract, so we have two positive variable terms. We're going to subtract the one that's smaller. So we'll subtract the 3n from both sides. The reason we do that is when we subtract that, we're not dealing with, this is gone, we just have 8 left over here, greater than symbol. We're just dealing with positive 6, so 6n minus 3n is actually positive 3n, minus 1 here. We don't have to deal with any negative variable terms. All right, and if we add 1 to both sides to get rid of the constant, 3n is still by itself. It's greater than 9. Now there's just a number in front of the variable, and since that's a coefficient in front of it that's multiplied by it, we do the opposite, which would be divide. So n is now by itself. Greater than symbol comes all the way down. 9 divided by 3 is 3. And there's no switching of the symbol because we did not have to use the negative rule, and we have the variable in front. So that is our solution set. Anything greater than 3. So like 4 should work, 5 should work, 6 should work. And you can plug any of those in there, and it should work out. I'm just going to do a mental check. I'm going to plug in 10. Left side, 10 times 6 is 60, minus 1 would be 59. Let's see if that's greater than 3 times 10, which is 30, plus 8 is 38. And 59 is greater than 38, so that works. All right, we're going to do one more problem together. And this is just for part A, just so you know, we're breaking this section into 2 parts. This is the first part. Last problem. Similar to the last one. Well, let's see what we have to do here. What are the solutions of 15 is less than or equal to 5 minus 2 times 4m plus 7. So here's what we're going to do. Since we like to, I'm going to write it bigger, is less than or equal to. Whenever there's subtraction, remember, change it to plus a negative. That will help you here. So plus a negative 2, that's multiplied by m plus, sorry, 4m plus 7. Now, I hope you notice here that um, there is some distributing that you have to do first. If you look, there's that negative 2 that's in front of the parentheses. So we're going to distribute that to the 2 things inside of the parentheses first. So when you distribute that negative 2 to the 4m and to the 7, well, we still have the 15. We still have less than or equal to 5 plus, let's see what's here. Negative 2 times 4m would be negative 8m. Negative 2 times 7 would be negative 14. Now that we're done with, well, we're not done with step 1. We did distributing property. Is there any like terms that we can combine? I think there are. On the right side, we have the 5, and we have the negative 14. So everything else stays. 15 is less than or equal to, we'll have the negative 8m in front, and 5 plus negative 14 is going to be negative 9, so plus negative 9. Alright, let's see, we have a 2-step inequality. Let's get rid of the constant here that's on the same side as the variable. We want the variable by itself. So we're going to add 9 to both sides to get rid of that negative 9. So we have 24 less than or equal to negative 8m. Now it looks like to solve for m, we have to do the inverse, which is dividing by negative 8. And remember the negative rule. We're dividing by a negative, so we flip the symbol right away. So we have 24 divided by negative 8 is negative 3, greater than or equal to, this cancels out, so we have m. Now, that's beautiful. We have the m all by itself. There's just one last step that I expect, and that is to rewrite it with the variable in front. So the variable is in front. We flip that to the front. We flip the number to the back. We also have to flip the symbol then. This is the second time we're flipping the symbol in this problem, and that's okay. But if we're flipping everything over, we're also flipping the symbol. That way it's still opened up towards negative 3. And that is your solution set. Anything less than, so m is anything less than or equal to negative 3. If you'd like to graph that, it would look like, there's going to be a nice, beautiful number line here, because that's how I always draw them. But as long as it has negative 3 on there, since it has the equal sign underneath it, we're going to have closed circle. Less than or equal to negative 3 would go that way. And that's the way it's pointing. All right, so that is section 1. Again, this is our goal is to, sorry, section 4, part 1. That is our goal, is to solve multi-step inequalities, and we did that. Looking towards next time, though, next time we're actually going to Solve multi-step inequalities with special solutions. So we'll talk about that next time. All right, have a good rest of your day.